Good morning, students. Today we are going to continue our last class portion, mesh analysis. Last class we have discussed about the procedure to be followed for the mesh current analysis method by inspection method, direct inspection method. Today we are going to solve the problem based on that procedure. Let us consider a circuit diagram which consists of the 3 loops and find out the unknown quantities of current. Let me take the circuit diagram as shown in the figure. And the source is 30 volt supply, and the resistance are 2 ohm, 3 ohm, 4 ohm, 5 ohm, 3 ohm and 2 ohms. Consider this circuit and find the mesh currents. As per the procedure, first we need to find out how many loops are there. By seeing this diagram, we can say 3 loops. That is, this is the loop number 1. So, name this is loop number 1, this is loop number 2, and this is loop number 3. And then next step, we need to see whether the current direction for each loop is given or not. It is seen that there is no current direction given. So we can assume the current direction as per the procedure. Assuming which we can assume in the clockwise direction or anti-clockwise direction in each and every loop. I am going to assume clockwise direction for each loop. That is, this is the current flowing in the loop number 1. So I am mentioning this current as I1. Similarly, considering the second loop, the current direction is taken in this way and designated as I2. Similarly, in the third loop, it is taken as in the same way I3. We know that this can be taken in the anti-clockwise direction also. But in this problem, I am going to consider clockwise direction for the all the loops. Okay. Then now, since it is a 3 loop mesh method, we are going to see matrix equation for this 3 loops. That is, as per the procedure, we know that R matrix multiplied by I matrix is equal to voltage matrix. Now, we need to expand this one according to the number of. Since there are 3 loops, the resistance maxis will become 3 plus 3, that is R11, R12, R13, R21, R22 and R23. Similarly, third R31, R32, R33, and the current matrix will be the unknown current values I1, I2, I3, which represents the unknown values of the currents in each loop, which is equal to voltage matrix. That is V1, 1 represents the first loop voltage, 2 represents the second loop voltage, and 3 represents the third loop voltage. This is your core equation. That is main equation for the given problem. So now we know this is the core equation in which we are going to substitute all the unknown and known values to find the unknown values of current I1, I2 and I3. Here R11 and all the values are calculated as per the procedure what we have discussed previously in the class. So what are the values? We know R11 value we need to calculate, R22 value we need to calculate, R33 and R12 which is equal to R21. Similarly, R13 is equal to R31, R23 is equal to R32, and the known voltage is V1, V2 and V3. First we need to find all these values. Then substitute all these values in the core equation. Then we can find the values of I1, I2, R3 in the next steps. First R11. What does it mean? R11. 1 represents first loop, 2 represents second loop, 3 represents third loop. So R11 means you need to consider only first loop, all the resistance you have to submit. Considering this first loop, how many resistors are there? 1, 2, 5 is common to first loop and second loop. So we should consider, whenever you consider the individual loop, when you consider this loop, you should consider 5 ohms. Similarly, when you are considering the second loop, that time also you should consider 5 ohm resistors. Okay. Now, R11 means first loop alone. First loop alone, how many resistors are there? 2 ohm resistor and 5 ohm resistor. So you add it is 2 plus 5, which is equal to 7. Similarly, R22. 22 means the second loop alone. Second loop, how many resistors are there? 5 ohm resistor, 3 ohm resistor and 3 ohm resistor. We all add resistors. 5 plus 3 plus 3 is equal to what? 11 ohms resistor. Similarly, now we consider the third loop. The third loop alone we have 3 ohm, 4 ohm and 2 ohm. 3 plus 4 plus 2, which is equal to 7 plus 2, 9 ohms. Then come to the non-diagonal elements. Diagonal elements are base positive. Non-diagonal elements come to non-diagonal elements R12. R12, 1 represents first loop, 2 represents second loop. Similarly, it is equal to second loop and first loop. Both are equal. That's why it is equal to equation. First loop and second loop common resistor. Meaning is R12. R12. First loop, second loop, common resistor. When you are considering this circuit diagram, it can be seen that first loop and second loop, the common resistance is 5 ohm resistor. What is that? 5 ohm. Similarly, R13, R31. First loop and the third loop, there is no common resistor in this loop. So we can say this value is equal to 0. Similarly, when you are considering the second loop and third loop, the value will be 3 ohm resistor. And the important thing here is whether the non-diagonal elements are positive or negative. It depends upon the current direction in that particular element. When you take R12, you can see this is R12. What is the resistance? 5 ohm resistor. 5 ohm resistor. What is the current which is flowing through the 5 ohm resistor? Since this 5 ohm is common to the first loop and second loop, I1 current is also coming, I2 is also coming. Both the currents are coming. So we need to consider both. So when you are considering I1, it flows from this way, we go this way. I1 comes here. That is I1 which is flowing through in this direction. That is from the top to bottom. Similarly, when you are considering the second loop current named as I2, it is flowing from this way and then in this direction. That is from the bottom to top. In this way. That is what? I2. Right? Now we can see the current direction, both the current direction I1 and I2 both are in the opposite direction. Since both are in the opposite direction, you should put negative. Suppose if you have assumed the I2 in the anti-clockwise direction, on that condition I2 also will come in this direction. That is same direction from the top to bottom. So that what you have to consider, both are in the same direction. On those conditions, you have to put plus. But here both are in the opposite direction, we should put negative. Similarly, 1T, it is 0 value. Then go to 2 and 3. R2, 3. 2 and 3 common resistance. Second loop and third loop common resistance. That is 3. Similar to the first loop and second loop common resistance conditions, apply the same current concept here. I2 flows from top to bottom and I3 flows from bottom to top. Both are in the opposite direction, so students, we need to put negative here. Understood? Yes. Now you have to put the battery values, that is input, that is voltage values. V1. So V1 means the voltage value appeared in the first loop. What is the voltage value appeared here? It is given 30. Here also the magnitude, positive or negative. The value is positive or negative are the important thing. Positive or negative. Here when you consider the current direction, it is flowing from this direction to this direction. That is clockwise direction. Actual current direction. What will be the actual current direction? In electrical systems, actually the current always travels from higher potential to lower potential. Higher potential means positive, lower potential means negative. So it will travel from this one. and you can see this straight lines, not curved lines. This is the actual current direction. So when you are seeing the actual current direction, which is a straight line, which are straight lines, and the curved lines, which are nothing but the current directions for the loop on what we have assumed, both are in same direction, same. This also travels from positive negative, this also travels from positive negative. So what we need to put means, since both are in the same direction, we have to put positive. Suppose if you are having the voltage then positive on this way and negative here, assuming that it will be opposite to the I1, that is actual current will be comes into the opposite direction of the actual direction. That is not actual direction. Actual direction of the current flow will opposite to the assumed direction. So both are will be in the opposite direction. Then it will be negative. Understood? Similarly, when you come to V2, V3, 2 and 3, you can see in the second there are no voltage source here. So we need to put 0. We need to put 0. Similarly, same condition. Come to the third loop, students. You can see in the third loop also, similar to the second loop, there are no sources. So the value of the voltage V3 will be equal to 0. Now in this matrix equation we have all. So you substitute all the values. So I am going to substitute the values of the resistance matrix. What are the resistance matrix? You can see values are R11 is 7, 11, 9. Similarly, R12 minus 5, R21 minus 5, R13 0. This is also 0, and this is minus 3, and this is also minus 3. I1, I2, I3 are unknown quantities. Similarly, when you are coming to V1, V2, V3, we know that student calculator, please allocate calculators. Calculators are calculator. Okay, substitute V1, V2, V3. V1, what is the value of V1? 30. V2, 0. V3, 0. Now we have the elements for all the batteries. From here, we can calculate the value of I1, I2, I3. Can anyone give me the calculator? Sir, calculator. The calculator. And now take all these things. See, this is the resistance, that is the current and the voltage matrix. Now, we are going to find I1, I2, I3 by the method what we discussed in the previous class, that is called as Cramer's method, Cramer's rule. See, Cramer's rule. By this, we can find the value of I1 which is equal to L1 divided by L. I2 is equal to L2 divided by L. Similarly, I3 is equal to L3 divided by L. These are the formulas for this one. Tell me what is del? Del is nothing but the determinant of your resistance matrix. What is the determinant of resistance matrix? We have the values of the resistance matrix. So just to take the determinant of this one, that is minus 7, minus 5, 0, minus 5, 11, minus 3, 0, minus 3, 9. This is the del value. Need to calculate. Similarly, del 1. What is del 1? Del 1 is nothing but you have to replace the first column of the resistance matrix by the voltage matrix. Just to remove all the elements in the first column of the resistance matrix and to replace that by the voltage matrix. So that what will happen for the first column, it will become 7 will become 30, 0, 0. All other elements remains same as it in the resistance matrix. That is minus 5, 11, minus 3, Similarly, the same way, calculate the values of del 2 and del 3. What is del 2? Same way, del 2 means second column. Remove the second column. So it will become 7 minus 5, 0. This will become 30, 0, 0. Third will become 0, minus 3, and 9. And then what is del 3? Same del 3. Del 3, you have to replace the third column by the voltage value. So it will become 7 minus 5, 0, minus 5, 11, minus 3. This will become 30, 0, 0, which is equal to the value. Now, in step by step, you find the values of del 1 and del 2, del 3 using calculators or directly by applying the determinant finding method. So, del value. Can any calculator tell me what is the value of del? And then del 2, del 3. Del, simple procedure, as you know. So, finally, after finding the values of del 1 and del 2, del 3 and the denominator del, we can find del 1 by del, I2 is equal to del 2 by del, I3 is equal to del 3 by del. We can find the details on the right. So, it will become this value. You can use your calculators to find these values or directly by using the actual mathematical methods. So, minus 7, 11 into 9, minus of minus 3 into minus 3, minus of minus 5 into 9 minus 0. So because 0 into minus 3 will become 0 plus 0 multiplied by anything will be 0. Anyhow I write minus 5 into minus 3 minus 0. So this term will become total amount will be minus 405. In the same way, we can calculate del 1, del 2 and del 3. So the del value for all the values are same.
2700.
And the del 1 value will become 2700. So the current value will be similarly in the same way when you calculate the other values, del 2 and del 3 will be obtained as del 2 will be 1350. Similarly, tell me the del 3 value so that the problem will be 1350. How much?
4, 5, 0.
4, 5, 0. Now you substitute 4, 5, 0. Now you can calculate. I1 equal to del 1 by del 2, which is equal to minus of 6.66 ampere. Mentioning the unit is very important. You should always mention that. Similarly, I2 minus of 3.3, and this way will be minus 1.11 ampere. So I1 is equal to minus 6.66 ampere. I2 is equal to minus 3.33 ampere, and I3 is equal to minus 1.11 ampere. See, the minus value indicates nothing but that you have assumed one direction. For the first two, you have assumed in the lateral direction, right? That is, this minus sign indicates that the assumed direction should be actually comes in the opposite direction. You have assumed in the opposite way. So the negative doesn't mean this is the incorrect, this is correct, but it means that the current direction what you have assumed should be in the opposite direction. This is the actual meaning. Please copy. And this is the general procedure. This is the same procedure. In these type of problem, we have solved a very simple problem in this category. We have started with this type of problem, right? And you can solve the same problem in many circuits. Few circuits I will draw. You try to solve. We will discuss the same problems in the coming classes. So, next problem, the same type categories, right? We will see in the next class. Take the next problem. This is another problem. In the same way, we need to find the battery voltage in this group is 30. This one is 10 volt. This one is 6 volt. Let it be 1 ohm, 2 ohm, 3 ohm, 4 ohm, 2 ohm, 1 ohm, and 3 ohm. Similarly, another type of battery you can see 200 ohms, 60 ohm, 40 ohms, 60 ohms, 20 ohms, and here also I am going to add one more resistance 100 ohm or the supply voltage of 10 volts. So let us see these two circuits. Apply the same concept what we have explained in the previous problem. Very simple. If you apply the concept, then you can easily find. Okay. See this diagram. Tell me how many loops are there. By seeing the diagram itself, we can easily say this is one loop, and this is one loop, and this is one loop. Sir, I want to take this is first loop, and this is second loop, and this is third loop. Sir, I want to take this is first loop, second loop, and this is second loop. You can assume, no problem with that. You can assume it any day, any fashion. But the procedure remains the same. You have to consider the actual current direction. So in this problem, you can say I am going to take this is first loop, this is second loop, and this is third loop. What? How many loops are there? 3 loops are there. So is there any current direction given? No. So that what is the condition? You can assume. So I am going to assume the same direction. In this direction. In this direction. Sir, I don't want to assume in the clockwise direction. I want to assume in the anti-clockwise direction like this. No problem, you can assume. But when you are writing the equation, you should consider this current direction in the proper way so that you can put minus and plus in the respectively. Otherwise, your answers will come in the wrong way. So, how many currents are there? I1, I2. Similarly, this one, I2. same matrix R11, R2. Find all those values. Simply R11. What is R11? The loop resistance 1, 1. 1, 2, 3. All the resistance at 1 plus 2 plus 1. 1 plus 2 plus 1 is equal to what? 4 ohms. Similarly, second loop 1, 2, 3, 4 resistance. 2 plus 3 plus 2 plus 4. R2. What is the value? 2 ohms plus 3 ohms plus 2 ohms plus 4 ohms. Which is equal to what? 5 plus 6, 11. Similarly, R33. Come here. 1, 2, 3 resistance are there. 1 ohm, 4 ohm plus 3 ohm. What is the value? 8 ohms. Now non-diagonal elements. What are the non-diagonal elements? R12 is equal to R21. R13 is equal to R31. R23 is equal to R3. R12 and R1 both are same. First loop and the second loop common resistance 2 ohms. Positive or negative? See, I1 come in this way, I2 come in this way. Both are in opposite side, so defaultly it will become -2. Come to this R13. The previous problem there was no common resistance between the first loop and the third loop. But when you are considering this diagram, first loop and third loop have a common resistance of 1 ohm. So you have to put what is that value? 1 ohm. And the positive or negative is important. For positive or negative, you can see this is coming in this way, top to bottom, and this is also coming in this way, top to bottom. But when you are seeing in some other loops, it is in the opposite direction. That's why negative came. But here, when you consider 1 ohm alone, I1 comes in this direction, I3 comes in this direction. Both are in the same direction. Since both are in the same direction, this value will become positive. This is very important thing in these type of problems. If you forget about these things, then the total problem will be go wrong. So students, please remind this clearly. And similarly 2, 3. When you consider 2 and 3, 4 ohm is the common one, and current direction I2 right to left. This also come in this direction, right to left. That is this way. Both are in the same direction, so this will be plus. Now you have the elements for all your matrix. I1, I2, I3 are unknown quantities. What we are going to measure? R matrix. All the values you have. When you consider voltage matrix, come to voltage matrix. V1, V2, V3. This is very important. V1, V2, because in the previous problem, which is very common introductory problem, there we have considered only one voltage is in the first loop, which is in the first loop. But when it comes here, I have considered 3 voltage sources available in all the loops. When you come here, it is 30. So 30 will be the. When you are coming here, what is the value for 10? When you are coming the third loop, it is 6. But the sign positive or negative. Again, it depends upon the current flow. I have assumed in this way, and the actual current direction, linear line, straight line, in this way, both are in the same direction. So this will become positive. Similarly, when you are coming to the second loop, you see current direction assumed in this way, but actual electrical current flow direction, which is higher potential to lower potential, usually we mention in linear lines from here to here, here to here, here to here. You can see both are opposite. This is in this way. Actual current direction in the opposite direction. So what will be the sign for this one? Since both are in the opposite direction, it will become negative. Similarly, come to the third loop. Plus 6 is the voltage, and this is the current direction. I have assumed this way, but actual current direction this way. Both are same. Both are same, so this will become positive. Now, students, you understood these are all the elements of your core matrix. R into I into equal to. Now you substitute all the values in this matrix. Find the determinant of R matrix del. Replace the first column by voltage matrix, that is del 1. Similarly, second column by voltage del 2. Similarly, third column by the third voltage matrix. You can find it there. Now take the ratios. I1 equal to del 1 by del, I2 equal to del 2 by del, I3 equal to del 3 by del. You can find the values of I1, I2 and I3 below. Suppose if you are asked to find the value of the current which is going through the 2 ohm resistor, what you will do? 2 ohm resistor receives the current from the first loop, also second loop. You have to check both the current values. I1 in this direction, I2 in this direction. So both the currents are same direction. So you have to put I1 plus I2. So whatever values you are calculating from this Cramer's rule, I1 and I2, added together, that implies the current which is flowing to the 2 ohm resistor. The same condition can be applied in the all the branches of the given circuit diagram. So students, this is the procedure to solve the mesh analysis. In the same way, you follow the same procedure for the next problem given in this diagram also, and find the current and the power in the 200 ohm resistor. This is a very important type of problem, similar to the previous problem what we have discussed. Complete this one. We will discuss in the next class. Thank you.